Hello everybody, and happy belated New Year. What we are going to talk about today is the importance of studding. Now, we did do another video a while back, which is a studded 13B, and we did discuss it while we were building the engine. But we're going to focus a little bit more today on what the importance is of studding and why it is important to do the stud installation properly, meaning the machine work before the studs are installed. Okay, so we will be showing you not only some demonstrations of other design stud kits and other methods to do studding, but we're going to show you our own CNC machine actually performing the work. See you soon. So the importance of studding is to get the loads off of the factory alignment pins. So of course we have a factory pin that goes into the upper corner and a factory pin that goes into the lower corner. What we accomplish with studding is to try to accurately machine all the holes in a way where our studs will be more of a slip fit, not interference fit, but slip fit like this that Mazda did from the factory, with a complete one-piece stud that goes all the way through the block assembly. So again, very tight slip fit with almost no movement, no play there, just like the stock dowel pin. Okay, and the biggest reason studding is desirable or recommended in the first place is in the combustion area. You have heavy loads that go against this cylinder wall here. If the engine detonates, which puts a much bigger shock load on the housings, the load will transfer from the rotor housing into the pin, into the iron where they are only countersunk a small portion. So, looking at this front iron, you'll see they only drop down that much. It's about a centimeter. And what happens when there is a problem is that portion of the housing cracks from the extra loads that go this way or that way. So in the event of putting in a one-piece dowel, which is what some people do, so it's basically two of these put together, and some people use solid, or some companies sell solid dowels or hollow dowels in one piece. The reason this doesn't do a whole lot is because if you look at where the two factory dowels meet, is in the center of the middle. You've got ample support here, but you don't have a lot of support on the ends, on the front and the back, with that small countersunk bore. So this has never really been a problem. People don't break center housings. What people break is front or rear irons. So this design that Mazda has where they meet in the middle seems to be perfectly strong, and I don't think that one-piece dowels are really going to do a whole lot for breaking front or rear irons. It may give a bit more rigidity to the block as an assembly. So again, what we're doing with studding is we're running one-piece studs all the way through the block. Now these are 12.7 millimeter studs, half-inch chrome moly. It's a very strong material, and this material will grow and will stretch with heat and allow the block to expand and contract. And the beauty of these studs with the 1/2x20 thread is that the stud stays the same thickness from top to bottom. There's no compromise. What you'll notice with some of the stud kits that are sold out there, this isn't an these are actually not actual studs, but this is an example. Some people have a large material replacement bolt or stud, and it tapers down to the same 10x1 factory thread into the front iron. This does nothing in terms of strength additions. It is pointless, and it is probably the worst kit to buy. I don't know particularly who makes them. I've seen them, I've heard of them, I've taken apart some engines that have them, but any stud kit that has a larger shank and a big head on it, or a large nut that threads on the top that reduces down to the factory 10x1, it's a waste of your money. It is absolute garbage. There is no reason to buy any such kits. They'll do nothing for you. The weak link is going to be in the stud here. There is never any slip fit on this portion. What most people who sell stud kits, like the guys that make these studs, okay, they sell you a drill bit to drill all the holes oversize. And you cannot accurately machine all 5 pieces, or in the case of a 3-rotor, all 7 pieces, accurately enough by hand with a drill bit. It's just, all you're doing is drilling larger, oversized holes for clearance for the larger material stud. So going from this to this, you have more clamp load. You have what we refer to as a larger cylinder head bolt. But you do not have any benefit with the slip fit of a stud going through each hole, the same slip fit all the way through with minimal clearance. There's no advantages to using an oversized stud if it's not going to have precision ground exterior and slip fit. If you have anything more than a couple thou worth of clearance, it's no different than drilling a larger hole. So this is the factory, this is their stud kit to replace the factory tension bolts. And again, these are garbage too, because these threads are not machined. They're actually done with a die, and I don't want to talk about that. Let's focus on the slip fit. So this is just a larger 10mm bolt. Through a factory rotor housing, whether it has that clearance or it has this now larger clearance, because we've drilled this hole on the CNC machine to match our 1/2-inch stud, it doesn't matter. It doesn't matter if you have less clearance, but you still have clearance. You will not gain from the strength, which is the purpose of a stud kit. Can you gain from having better clamp load? A larger cylinder head bolt to suck the engine together more? Perhaps you can, but you can also accomplish a bit more of that by torquing the factory bolts a bit more. It doesn't really serve any benefits. Again, any of these studs that have the step down to factory 10x1, waste of money. Now, a lot of the stud kits that we've seen are just 4 additional 1-piece long studs, similar to ours, that are designed to go all the way through the engine in 4 locations: north, south, east, and west. Do I agree with it? Well, again, all you're doing is you're putting more clamp load on those spots, and you have a larger, more rigid bolt there. You're still going to have to torque your factory 10x1 bolts to the same specification as the large bolts. You don't want to give these more or less torque than those. You want to keep it the same. And putting 4 additional 1-piece studs, or putting 15 or 16, I should say, 1-piece studs, really doesn't make any difference. You're just exerting more clamp load, and that's all you're doing. So what we're going to do is take you over to the CNC machine and show you guys how we accomplish this slip fit all the way through the block. And this is very challenging. This is not an easy thing to do. We've had special jigs made, and we have a special process to actually do this. So by the time you're done and you have a stack of all your 5 pieces, you can take this stud and slide it right through the block assembly until it gets to the larger threaded holes in the front iron, which we're also going to show you how we bore out and tap these respective holes in the proper locations and increase the thread size. And here we go. Okay, the machine has finished the milling. So what we're going to do is we're just going to get rid of these chips real quick. Then we're going to put in the boring bar head again. And now we're going to run the same program over, but just do the final bore size on all the holes of the boring head. Here it goes. Now we may not show you all of the center and the rear. It's the same process, same tooling, and we will likely speed it up in the video so we don't have to bore you with the same thing. But it'll give you guys a good idea of how this is done. Okay, so that's the last hole for the rear iron. The very final step on a new program, we're going to mount the front iron and do the final tapping as the last step. Okay, and for the middle and rear irons, you can see we have the much larger slip fit .7mm holes. Okay, and last we'll show you the front. And here you can see the much larger 1/2x20 threads that we've machined into the front iron. And you'll see, again, these are much larger 1/2x20. There is going to be an incredible amount of strength when you have all 16 of the factory 10x1 bolts replaced with a 12.7mm stud. So just real quick, if we lay this down and we take one of our rotor housings and lay it on top and take 2 factory pins and put these in, and then we take our center iron and we put that on top here. This is a good example, a good representation of what things are like when you have the other 2 pieces stacked. And we could have done that for you quite easily, but I'm just going to show you the simple. So this stud will slip through every location of all these 16 bolt holes and give that slip fit all the way throughout the engine's bolt pattern. Okay, so one of the reasons we want to show you this on the machine is to show you how accurately things need to be done and how accurately positioned the pieces need to be before we do it. And this is a service that we offer not just in the engines we build, but a customer can send us all 5 housings, or in the case of a 3-rotor, 7 housings, and we will do all the machine work, thread the front plate, do the final test fitting, and then send you back a stud kit with 16 of these studs along with all the machine work. Okay, so in closing, I will just say this: be careful what you choose when you buy stud kits from different companies. The majority of them, in my personal opinion, are gimmick. They're not well designed or well thought out. They're designed to sell and make money. And again, if you're not reducing or completely removing the load from the factory pin locations, you're still going to have problems with cracking blocks, and you will still have no benefits from putting in any type of stud that has close to factory clearance or even tighter than that. It's just, in my opinion, not worth it. So get your block machined properly and buy a quality stud kit that functions.